Hello all, hello all, welcome to the, okay, just a minute. Satya, do you want to say something? Satya S?
Yes, yes.
Yeah, please.
Yes, sir.
No, do you want to say something?
Sir, in programming assignment 3. Sorry, sir.
Yeah, go on.
In programming assignment 3, I first submitted the first two problems which I solved and I got passed for that. But when adding the third answer to the list of answers in the editor, and after I submitted, it gave runtime error and did not go off. I
Third
got 0
assignment.
for that assignment, sir.
See, if you have any queries that you want to raise against what you have solved earlier or the way they have marked, you please take it up to the forum that is there. If you have any doubts related to the program you wrote, then we will get to that later. But if you have any queries,
I
or see, I do not check it. Okay, so there are specific
I
people
put
who
it in the discussion forum, sir. They said ask it in the doubt clearing session.
ask it in the doubt clearing session.
In fact, I even sent a mail to the professor, Professor Madhavan.
Oh, okay. So then what happened?
I did not get any response. That's why I'm raising it here.
Okay. Actually, I when did you raise it in the forum?
Immediately after the programming assignment 3 was evaluated.
Okay, so can you do one thing? Can you, do it again? I'll today after the session I'll go to that. I'll check it and I'll try to clear your doubt. Okay.
Thank
Uh,
you. Thank you, sir. Thank you
yeah,
very
yeah,
much.
yeah. You please do that.
Yeah.
See, this session also has aspects of doubt clearing, but this is basically an interaction session where we solve problems together and go through some tips and tricks and some new, uh,
Yes,
maybe
sir.
not
I
new.
understand. I
Yeah,
understand. Since I did not get any response from any of the
yeah. Okay.
forums.
Yeah, fine.
Okay.
I'll take care of that. I'll you raise it once more. I'll see. Okay, I'll see it tonight, or I'll let you know. Okay. So
Thank you, sir.
yeah. Yeah, so without any further delay, let's actually start our session. Welcome to the seventh session of programming data structures and algorithms using Python. Now I'll just share my screen. So, oops, okay. Uh, Sorry. Yeah. So as usual, let's. I'm sorry for this. Yeah. So as usual, let's go through a quick recap of this week. So we are in week 7, and the deadline for submission of week 7's assignment is, I think, tomorrow. I'm not sure, so please check that yourselves. And even week 8 assignment is out. So I hope you have attempted that or will do that. It's up to you. And week 8 is the last week, and we'll meet next week for week 8 one, and we'll also have one more session after that. I mean, the next to next Tuesday. So that will be our final session, and there we'll go through some more complex level problems. I mean, it will be like a conclusion to the course. Okay, to these sessions. So please bear with me for that. Okay, so in week 7, abstract data types were covered, then classes and objects, and then user defined lists. So in last week we saw how to write a function for delete max in a heap. So delete max is actually an inbuilt function in Python. So we can write that just to show that we can also write that on our own. We wrote that. So and so we have like uh, in for abstract data types. So we saw different kinds of lists, right? Like stack, queue, heap, and all. So how we differentiate them is each of them will have a specific set of functions that it can use, right? So like stack can use push and pop, queue has add queue and remove queue, heap has delete, max, and insert, and also within these functions heapify is also there. Okay, so so some of the functions like append, extend, and all can be used for all lists, but these functions are specific for that list. So once you call one function, once you call one uh, either push or remove queue or whatever, it will identify it as that specific data type, and then or that specific type of list, and then when you try to apply some other function on it, it might give an error. Then we saw classes and objects. So oriented programming is a very big and important concept in uh, Python, and actually in all programming languages. So in C, actually all class and objects are not there, so you can't do oops there. It's called object-oriented programming. In C++ and in other languages, it is there. So here we can, we define our own data types using classes. Okay, and then user defined list. So we saw that how all these list functions and other functions actually work. So within that class, these functions have been defined, like append or extend or other push, pop, and all. They have already been defined. Okay, so when you call those functions are actually getting called. Okay, so and we saw how those functions are written, and then we can also modify that according to our need. So we can define or invent, not invent actually, we can define a new type of list, a new type of data type, or we can have a user defined functions that what this function does, what that function does, etc., etc. Then we went through search trees, binary search trees in specific. So search trees. Okay, so yeah, so this one I have been trying to cover since last 2 weeks, I think. You must have seen. So since this one is somewhat challenging, so we'll just start with this. You all try this, and then we'll so uh, it'll also like get you back to di dictionaries again, right? Because that is a quite interesting concept. So once we are done with this, we'll also cover other things that we did in this week specifically. So the task you have in hand now is to write a program or a function, of course, to read a list of strings. So I input a string, sorry, I input a list where all the elements are strings. Okay, yeah, if a user does not want to do that and he inputs a wrong list, with some numbers or sub lists and all, you can actually write one. Of course, you all know that you can just write a condition using if, that if such error has been encountered, you can exit, or you can also use try, so that you don't abruptly exit. But now let's just assume that the input that we have is ideal. It is a valid input. So I take an input, and so I hope you know what anagrams are. So anagrams are basically two words with matching letters. Okay, so for example, in this example one, you can see listen and enlist. So both of them have these letters, LISTE and all. Okay, and these letters and these letters only. So even silent is there. So these three words can be called anagrams of each other. So that is and anagrams, and we can also, okay, in the next example it will be more clear. So what I want the function to do is take in this list, okay, of strings, and return a list with only the words that have anagrams. Okay, so now when you are writing, you can also use invalid words. Okay, like I've used it here. So it's just a string. Okay, word might not be in the dictionary, but the string is still there. But the string is a string. So I take in these words: listen and list, silent, hello, world, cat, and act. So as you can see, the first three words are anagrams of each other. So I have printed that, and there is no anagram for hello in this list. So I remove that, not remove, I ignore that. Then world is there, same thing, nothing. Cat, so I scan the list, I see act. So act and cat have the same letters, so I print them as well. Okay, and then next example is there. So could is there. So here conveniently all these anagrams are mentioned next to each other. So you might think that, okay, so I just removed these two words and printed them as they are. So I'm not actually doing that. That will be clear with the second example. So there is could. I scan the list. I find cloud. Okay, so I print could and cloud together. So this is actually cloud. I'll change it once. We exit the presentation mode. Then it is there. Okay, scan the list. I see hit, same letters. So I print it and hit. Then dog is there, nothing. Mad is there, nothing. Okay, then there is the eyes. Okay, so they are two words. So you have to make sure that when you're reading it, you ignore this blank space. Okay, so there are many ways to do that. In my solution, I'll show one way. You might have uh, you you can use whatever way that you feel is convenient. Okay, so I have the eyes, and anagram to that is desi. Okay, so I print the eyes and desi. So while printing it, I do print the space here. Okay, and then there is a so mad was not there. Then there is hit, and so hit we got already. Then there is sun. So sun also, sun is the last one, and since so it can't have any anagrams here. So that is what I want it to do. Okay, so now just sorry, yeah. So now I'll just so if the sorry, yeah. So some people have raised their hands. Screen freeze. There is a problem. We can't see the slides. Okay, so now can you see the now can you see task one? Okay, wait. Yeah, please tell me.
Yeah, we are able to see, but when you are explaining, we are not able to see that everything.
Explaining task one, or when we had gone through. Okay. So now you can see, right?
Yeah, only now we are able to see.
Oh, so I think there was a problem with the presentation. Okay, just a minute. I'll do that again, and you let me know if there is any problem. Okay. So can you see now?
It is still in task one.
Yeah. That's what.
Okay.
Task one is what I want to show. So okay. So is the task clear, or do I have to go through it again? Okay, huh?
Yeah,
If
please go through it once again.
okay. So I'll go through it once again quickly. I have to write a program or a function that reads a list of strings and groups the anagrams together and return them. Okay, so that is what I have to do. And anagrams, so you heard what I said, right? At least my audio was there, no?
Volume was there, but we did not understand exactly what is those
We know
anagrams
what
or.
anagrams are. We don't know what to do with the what you want us to code.
Okay, okay, fine, fine. So I take in a list of strings, as you can see in the example. So this list has these strings called listen, enlist, silent, hello, world, cat, and act. So I find out if within that list each string has an anagram. So anagram means they share the same letters. So for example, listen, enlist, and silent all have these letters LISTEN. Okay, so they are just combinations of these letters. Fine. So I take these, I take these in a new list, and then I see hello. So for hello, no other word in this list has the same letters. Okay, so and don't think that subset, superset, set and all, it should have exactly the same letters. Okay, not more, not less. Fine. uh, so you might think that if I have a word 10, 10 is a part of a listen, but no, it's not. We want it to be same. Okay, not less, not more. So hello, HELLO. None of the words have HELLO here. So I discard this. Then there is world, same thing. I discard this. Then there is cat and act. So cat and act both have the word, the letters ACT. So I print them. Okay. Second example, and yeah, of course. So the strings need not be meaningful words. Okay, I can have just a bunch of letters. I just want to see if it works or not. So I have used it here. You can see that there is a red curly line here. Okay, so it is not a valid word. So it and hit have the same letters. Okay, so I have printed, and what I have to do is I want to print them one after the other. Okay, so first one was really convenient for us because they were already grouped. So I printed them as is. I just removed hello and world, and I just printed the rest of the list as is. In the second one, so I see could. Okay, in this list, so I go through the list to see if any other word has these letters, that is COULD. So I see that cloud has these letters. Okay, so I print could, then cloud, then I see it. I scan the list again. I see hit. So I print these two. Then I see dog. I scan the list. Nothing. So I discard the word. Then mad is also discarded. Then I see the eyes. Okay. So like I said then, if there is a space in between, you have to find a way to remove that space and then check. Okay, because here both of them have spaces, so that is more convenient. But sometimes so okay, I'll give you one more example when I'm solving, where you will see the need to remove that space. Okay, so there can be many ways to ignore that space. So you choose whichever you find most convenient for yourself. Okay, so the eyes is there and they see, so they are also anagrams. Okay, so I print them. Cloud is there already, so I don't need to go back. Hit is also there, and sun is there. So sun, none of the words have the same letters as sun, so I discard that. Fine. So did you understand what you have to do? A thumbs up would be
Yes, sir.
okay. So I'll give you 15 minutes. All right. And will that be enough? Okay. Yeah. One of you, Vidyashri has raised her hand. Do you have any doubt? Okay, then I'll start the timer. I think this is the only this and maybe one more will be the only programs you will be writing in the class. Rest you will I'll ask you to solve questions, so it will be more interactive that way, because this is this gave you the task and it will feel like that. So all right. So the timer has been started. You have 15 minutes. Uh,
Yes, sir. I want to ask that, we have a word like TER or another word PEER. So I want to ask that PER um, is an anagram of TER, but here we have double E in it in the PER word. So double and in TER only we have a single E. So by from the double E, can we say that it is a anagram of TER?
So see, like I mentioned, subsets are not allowed. So PEER is PER lies in PEER, okay, but subsets are not allowed. They have to exactly match. So if I have PER, I can have REP, rep, per, rep, or ERP, only those. I can't combine them with PEER, okay. And if I want something for PEER, I can have PERE or PREE, something like that. But it should be exact, okay, not more, not less.
Okay.
So time's up. I hope most of you were able to code this. So now let's go look at the solution. Okay, so I hope this is visible. Screen is visible. Okay, so I'll define my function. And input will be, let's say, my string list, right? So I'll just write it as ls, and so I'll be using dictionaries for this. So I'll just initialize a dictionary. You will know why. Okay, so I have defined an empty dictionary. Now I'll see the letters in all the strings in that list. Okay, and I'll create so I'll create the keys as though as the bunch of letters, and then I'll add whatever word has those letters as values to those keys. Okay, so let me just scan this for s in ls. So I'm scanning this. So to find if all the letters are there, I'll first sort this. Okay, so I'll call it sorted as. So before sorting, I'll check whether any gap is there. So I'll join gap as in any space, right? So like I said, if space is there, I need a way to ignore that space. So I'll use join. So wherever it encounters the space, it will remove that space and join the left and the right part of the space. So that's what it does. And also I'll use sorted here to sort them in a particular order. Else I so this sorting will make it easier for me to get the letters in a way. So if I sort the word listen, uh, the smallest letter is E, right? So so listen will become EI L uh, EIL, then uh, a T, sorry, N, S, and T. Okay, so so that's the way we'll sort that, and then so if we sort them all, then we can say that these two are same. I mean, we can directly compare and check if two of them are same or two of them are anagrams. Okay, so that's why I'll use sort, and sorted, like it returns the sorted one, right? So since it returns that, I'm storing it in sorted s. Okay, so and yeah, then now I'll check if sorted s is there in my anagram dictionary, right? Sorted s. Mic is on. So I'll check if it is there, right? If it is there, then I'll just add whatever this thing s to my as a key, right? Sorry, not a key, a value. So this is a key, and I'll add the words with the same letters as dot append as values to the key. So if I have this list, if I have this key called EI EILNST, then I'll append. I'll first see if I'll first see if it exists in my in the dictionary that I have created. If not, I'll first create that, and then I'll add and then as keys I'll add the words that have the same letter. So that is why I didn't use s dot sort. Okay, if I use s dot sort, then I lose s. I mean my s will become sorted. So s, but since I use sorted s, that way I'll get an output. Okay, so s is still s, and I've stored the sorted version as sorted underscore s. So please keep in mind, okay, there is a specific, you use you use dot sort and sorted wherever they are needed. Okay, so you can't they can't be exchanged. So yeah, of course, so if it is not there, I'll create that key, and of course I'll add that element, okay, as a list itself. I'll add that word as a list. So that way, so when it encounters it again, this sorted s in this, it'll append the next word with the same letters to the value, to the particular key's value. Okay, so now I have to remove the ones that are not anagrams. So the easiest way to do that is, so if one word has has an anagram, that way that key will definitely have more than one values. If there is only one value, that means that word is unique, and no those set of letters are unique and no anagram is there. So I'll write a small function for that in place. So I'll call it groups, let's say. So I just want to extract the keys and their values where only anagrams are there. Okay, so I'll write this function in place called groups. So I want group where for group in so like I said, it will extract the values. Okay, extract the values in this where in those keys where the values in that key is more than one. Okay, so this might sound a little confusing. So keys are there and values are there. So it will go through all sets of values. Okay, so it will go through each key and its value, but it will not regard the key. It will disregard the key. So it will just count the number of values in each key, and wherever more than one value per key is found, it will return those values. So those values are the ones which are anagrams. Okay, so and that has been saved in groups. Now all I have to do is I'll flatten this list out. Flatten it out means, yeah, so they are already what is it called, they are stored as lists, right, uh, sublists. Since I have put what is it called, this thing here, so I'll have to flatten it out. So for that I can just write, yeah, I'll save this as anagrams. So you might see that I've called this twice. Okay, I've used a nested for loop in this on spot function. Just return anagrams. Okay, so what am I doing here? S in this for loop, yeah. So this line is just to flatten it out. Okay, so I'll just write flatten it out. So this is one. This is the main for loop, and this is within, right? So normally when you write nested for loop, the larger for loop will be on the top, then within that smaller loop will be there. So but the way we read is we enter, and to check the condition we go from bottom to top, right? So that's how even this works. So S for group in and groups for S in group. Okay, so I'll run this, then I'll come back to this line. So I'll just call it here itself. So my input is like this. So what were the words? Just give me a minute. I'm gonna paste it here. Okay. So this is some quote error. Oh god. Okay. Now I'll call the function. So I'll print it as result equals. So what was my function called here? str. String is data type. Okay, let's see if it works. Now since I'm running this for the, okay. So yeah, I have made a small mistake here. I forgot to, so it will not directly compare the number of values. Okay, so I have to, sorry. So length of each sub list is there, right? So each key has values. So those values are in form of a sub list. So so they are group. So when that length of that group is more than one, I'll return this. Okay. So now it works, and yeah, I have to sorry, I have to print the output. So I got yeah, cloud could it hit the eyes they see and all. Okay, so now I'll show you one with multiple spaces. So I'll remove this and write a decimal point, and instead of mad I can probably write I'm a dot in place. Okay, so this has two spaces. Here I have 1, 2, 3, 4, 4 spaces. Let's see if it reads it. So it did not read this. So I think number of spaces is also one problem here. Yes. Yes. So where do you think the mistake can be? Right. Yeah.
The join function.
But it works for one letter words. What I mean is, so I'll wait. Yeah. So I'll use this. And instead of this, I'll just write so it has printed this. Now I'll do this. Oh, okay. So it has removed all these spaces and it has joined. Okay, and if I do the same thing for signature, okay. Oh,
Print it in the next line. Then I'll be sure if spaces are not being counted.
what?
Print sorted X in the next line.
Yeah, it is being. Oh, fine, fine. Sorry. Will this work? See, they are the
See,
same.
it's no, it's counting the, it is counting the spaces and putting it right at the beginning. That's why I said put it in the next line.
Oh, right. Yeah, yeah. Now it makes sense. So yeah, one extra space is there, like you can see.
Two, true sign, two extra spaces.
Oh yeah, right, right. Two, two, two. Here two, and here there is only one. Oh, it took those two spaces and it inserted here. No, but here it's inserting one space. Okay, I think I'll. Yeah, I might have made a small mistake here. Okay, let's just compare these two. Uh, this the eyes and they see. Okay, so they have the same number of spaces. That's why it's okay. So here there is one space. Here there are two spaces. So no, but even here the spaces are not. I mean, they are off.
Do print sorted X in the next line instead of putting a slash in, then it'll be more clear.
Right, right. Sorry, just. Yeah, so now it's same, right? And even here,
Now
uh,
let's try signature and they sign, a true sign.
ooh, so these two spaces, it's just counting it, right? You see
Yes.
what is happening here. Oh, so that's the problem, right? Yeah, so I wait. So wait, let me just. Hmm. So yeah, so what method uh, should you guys use to remove that space?
I couldn't figure this part myself. Just realize what is happening.
All right. So like you can see, space is like zero, right? So space has priority over A. Uh,
There's a remove space function, right?
yes, yes. So actually, yeah, I didn't want to use that, but let's see if it uh, works. It's called reduce.
I thought it would be strip. Strip L, if you do strip L after joining,
Oh
you can
yeah,
see
L
the
strip.
left.
But L strip and R strip, it's for left and right now.
So we need all the spaces are coming at left, right?
Oh
So
yeah,
after the
right, right, right. Yeah, you're right, you're right, you're right. So L strip. L strip is not defined. Yeah, I think I have to call that because I'll have to name error trace back. Yeah, L strip is not defined. I have to include one that function. Just a minute. Okay, so my bad.
You can use your replace function with the for space with the empty quotes.
Which function?
Replace
Replace.
string
Oh,
dot replace.
yeah, right. Even that's also an option. For with space, I can just use empty. So or wait, I'll just wait just a minute. Sorry. Yeah, I was not using the function properly. So now, oh god. So there seems to be a small glitch. Yeah, so I replaced one space with no space. So, but it's for some reason it's still not working. It should work. Uh, but yeah, that is one more small problem with Google
Can
Colab.
you use single quotes?
Yeah, even that will okay. Why not?
Why don't we use lstrip on both sorted S and sorted X and then check if it is coming equal?
Else stripper or see the thing with Google Colab is if I run it now and if I run the same thing later, it might not give me the same output. So I have faced that
Both,
a few times.
try with both sorted S and sorted X, and
All
maybe
right.
we'll see they both have the equal. Do it. I
Uh,
am. Oh.
yeah, there is some problem here. I don't know how it's happening. Yeah, I mean, I have encountered it in Google Colab a few times. So we write a long code. We run it. Some error will come. I'll open a new notebook. Write the
I
same
think
thing.
the dot join is making problem.
Oh, this dot join is making an issue. Yeah, even okay. So that's also a good idea. It's a great idea actually. So I'll. Oh no, it's so
Instead of strip, use replace.
why not? Yeah, so some attribute error. List objective has no attribute. Okay, so is it why is it reading? Oh, so sorted will return a list. Sorted will actually
Yeah,
return a list.
actually, replace is for string. It's a string function.
Yeah, and then sorted will return a list. Sorry,
Yeah.
sorted is for a list, so it will actually return a list. So that's
Give a
why.
subscript.
So then let's write sorted.x or replace before the sorted. No, let's put replace before sorted and then dot it.
Hmm. Oh yeah, correct. So that's how we debug. This has turned into a debugging session. So wait, there is no. Oh right, for this word itself, right? So s1 equals s2 equals. Oh yeah, so like I said, sorted will return a list. So so
And
there is.
it's not removing the spaces.
Yeah, it is not removing the spaces for some reason.
So try strip.
Yeah.
Last thing, try strip and then then not else strip, just strip.
Oh yeah, right. Oh yeah, not leading. Sorry, not left or right, just strip. Of course. Yeah, like I said, sometimes Google Colab has that issue. So just I hope this code was clear to some extent. I believe. I think we have spent enough time on this. I'll get back to you on this for sure. So apologies for that. Uh, let's move on to the. So I'll actually we'll skip the next part. So I thought we could do the same thing but with lambda function. So we'll skip that for now. If we have time in the end, we'll get back to it. Okay. So yeah, so you must have solved week 7's assignments and you may have come across questions like these. So permutations, first of all, I hope my screen is visible. I think it is. So you must have come across questions in your assignment saying find the next permutation, find the previous permutation and all. So I'll give you a small task here. So I hope you know how they work, how permutations work. So your task is to find the previous and the next permutation of each. Okay. So in my first one has letters from A to H. Second one also has letters from A to H. Third one has from A to J. Fourth one is from I to T. So yeah, so I hope you know how we find the permutations and all. You take the shortest, longest. Uh, I mean, you find the shortest suffix. You find the longest suffix that can't be incremented, etc. etc. All right. So I'll give you 2 minutes for each.
Sir, I am not able to understand the question, sir. Can you explain?
So did you try the week 7's assignment?
There, yeah, I think it is the first question, sir. I am not able to understand
This is okay.
the.
This is I think second or third. I don't remember, but similar question was there. So I thought if I
So I
let you
remember
practice.
this question.
What was?
I know how, so I know how to get the answer, but I definitely don't know how to get the previous one. I don't know how to do it in 2 minutes. If I believe we are all in the same, we are all in the same boat. It's best if you start, if you show the answer as well, because I don't know how to do it in 2 minutes. It takes me a while. There's a common.
Okay, okay, okay. It's fine. It's fine. I'll. Okay, so let's just go to the uh, second one, I guess. Okay, so I'll. You know how to get the next one, huh?
From the last letter, we go back until there's a letter which is less than.
So see, we have to find the. Okay, I'll just show it how we do it. So we have this bunch of letters. Okay, I'll first show how we do previous, then I'll. Okay, no, sorry. Yeah. So we find the longest suffix that that cannot be incremented. Okay, the longest suffix that cannot be incremented. So here I'll basically find a bunch of letters. Wait, so suffix is just xfj. Wait, just give me a minute. So what I mean by cannot incremented is my first permutation is ascending order and last permutation is the reverse order. So cannot be incremented is that it is already in the descending order. Okay, so that's what I mean by that. And what I mean by, so instead of this, let's just I'll just get back. I'll just do the one that we have done in class itself. Okay. So here I find my longest suffix that can't be incremented. So in this I see that O and MJI are already in like O is 15, 14, 13, 10 and 9. Okay, so this is already there in the descending order and it is like five five spaces, right? And K is 11. So K is not part of this. So what we do here is to find the next permutation. I'll take this. This is my longest suffix here, which is in the yeah, which cannot be incremented. So then what I'll do is I'll find the one previous number. Okay, so I'll go to the one previous number, that is K. So K is 13 and I check this list, I scan this and see where I can insert K here. Okay, so not sorry, not insert K. So I find an wait, sorry, I have muted this for a while. Yeah, so so what I'll do here is I'll find one digit, one letter that is more than K. So the lowest letter that is more than K. Okay, so in this we can see that O, N and M are higher than K, J and I are lower than K. So I'll go for the lowest letter that is more than K. So that is N, right? So once I do that, I'll replace M and K. So I'll bring K here, I'll bring M here. Okay, so now I can see that this is in uh, descending order. So to finally to get the next one, I'll just sort it. So since I'll sort this in ascending order. So I mean this permutation concept itself sounds a little vague, and it takes some practice to get a hang of it. Okay, so I have to sort it in ascending order, but since it is in already the reverse order, all I have to do is I have to reverse the string. So I'll get actually, instead of doing that, yeah, so this one will be uh, D C H B A E G L M, and this O N K J I will get reversed. So I J K N O. Okay. So and now let's see that how we can find the previous iteration. Okay. So for this I'll only show the previous iteration. So like we saw the longest suffix that cannot be incremented here. So the next one, this is sorted, right? So I'll look for something like this. Okay, I'll look for something that is sorted. So here I can see that ADH is sorted. Wait. Okay, give me a second. Just a minute. Yeah, so sorry, yeah. So I can see that from the end ADH is already sorted. So instead of doing this, what I can I'll make this a little longer by saying AC. So ACDH is in the right order. Okay, so it is the shortest suffix that, sorry, the longest suffix that can be incremented. Okay, so like in this we saw that IJKNO is sorted. Okay, so to get the previous one, I'll find the one which is already sorted in ascending order. Okay, so this thing is there, ascending order, ACDH. Then I'll go to the previous one. Here it is F. Here it is M. So I'll see where I can insert M. Okay. So 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 F A C D H. So I want to insert F somewhere. So F is more than D, and sorry. So first, before doing that, I'll reverse it. Okay. So in this, what we did, we first swapped K and M. So it was in, and then we sorted that. So this, so first to bring this from this, I'll first take this and I'll reverse this. So I'll get MONKJI. So here I'll get F, and since I reverse this, I should get HDCA. Okay. So this has been reversed. Yeah, actually I feel 2 minutes was not reasonable. So uh, apologies for that. Yeah, this uh, session doesn't seem to be going so well. Anyway, so this remains the same. So I'll also write this here, EI BJ HGFCA. Okay. Yeah. So Sorry, I wrote the whole thing. Yeah, so F and HDCA is there. So with HDCA, now I have to find where F will go. So F will go here, okay, after H. So I'll remove the F and I'll bring F here. So when I was doing this, I had to compare K with the smallest one that was larger than it. Alright, so I had to replace that with M. So here I have to find the largest one with respect to F, that is smaller than F. So here since H is 8, F is 6, D is 4, C is 3, A is 1. So D is my option. I'll swap D and F and I'll get my answer that way. Okay, so yeah, this is slightly tricky, but did you get what I explained now, or do you want me to go through it again to find the previous one?
So previous one is what I got is that I'll start from the end and I'll keep checking if it is in order in the ascending order. As soon as it stops being in the ascending order, that is the letter we'll take, and we'll try to put in the next the letters that come next. Okay, now next letters we'll uh,
So wait.
and then I'll add F in the letter which is the after the letter which is maximum.
Yeah, so wait. So first, what I'll do is I'll go from the back. I'll start from the back. I'll find the sorted one. I mean the part
Sorted
where,
ascending.
yeah, in ascending order, and I'll stop my traverse when when it stops being that way. So that set that I found with in as ascending order, first I'll flip it. Okay, first I'll reverse it. Then I will take the next element. Okay, so I had
F for
ACDH.
the next element after it stopped being in ascending order.
Yeah. So first I had ACDH. I reversed it. I got
HDCA.
HDCA. Right. Then I'll take F. Though, so the next element that is there, I'll see where it belongs. Right. So I can either use terms like I'll take the
So one question.
uh,
This will be between H and D, right?
yeah.
Not after H.
So yeah. So that's what I'm coming to. So I am not trying to insert it. I am trying to replace it. Okay, so not replace. I am trying to swap it. So I can say that I can swap it with the largest value that is smaller than it. Okay. So in this, so since it's already in uh, reversed order, I just have to see where it belongs. I mean, between what two it belongs, and then I'll replace it with the next element. So I can see that it belongs between H and D, right? So H and D is there. That way, I'll remove D, not remove D. I'll swap it with D.
Swap. F should come after H, so swap whatever comes after H with F.
Yes. Not whatever comes after. Yeah. Fine. If F
Since
should.
H is the biggest one and F should have come after H, we'll swap whatever is after H with F.
Yes. Correct.
This is proceeding, and when you want the next one, we'll again go from the back and we'll
And
see
we'll.
in descending order.
Yes. Exactly that. Okay. So the way I knew only what is it called, the successive one, the next one, and I saw that how we can do this. So some things you I think in this week's, I think only the next one has been asked. So that's why you guys didn't think of what comes you guys only thought of what comes next and what comes, and not about what comes before. So this, okay. So yeah, so these are, since 2 minutes is less, what I'll do is you guys note it down, and
Sir,
yeah,
sir, sir, I will show the image where we have to convert each letter into numbers, sir. A is equal to 1, B is equal to 2, like that one.
So
How do you know whether A is less than B or not? Equivalent to decimal value, sir.
yes, equivalent
Sir,
so
sir,
so
sir,
see, in
sir, first I
binary,
share the equivalent, sir. Once shall I share?
share what? Share what? Share what? Uh, yeah,
Okay,
please.
sir. 1 minute, sir. 1 minute, sir.
Yeah, yeah, I can see. I can see. So in the dictionary, that is what the alphabetical order, right? No, no. I
Yes, sir. Yes, sir.
we can see your screen.
Okay, sir. Okay,
Don't
sir.
worry. Uh, you can stop sharing now. I know what you
Okay,
mean. Yeah, yeah.
okay, sir.
Please stop sharing now. Yeah. See, I know what you. Oh, okay. I know what you mean. So you just, in the dictionary order, in the lexicographic order, that's how it is, right? First A, then B, then C, till Z, Z or Z, whatever you guys call it. So that order, just to keep something in mind, we assign it. We can mentally assign the values 1 to 26. It's up to you, right?
Yes, sir.
Because that is what the dictionary does. Or you can also go to ASCII one, and you can say A is 65, B is 66 and all, but I'll not come to that, because so just ignore what I said about that. So just to keep a mental track of it, you assign them numbers just to compare them. Okay. So yeah, so so actually 2 minutes was pretty unreasonable. So what I'll do is I'll give this as sorry. Yeah, so what I'll do is I'll give this as homework, because I have a few more things to cover now. So yeah. So you also must have seen one question in your assignment, uh, which is called post order and in order traversal. So just to just say just give a thumbs up if you have come across this term in your assignment. No nos.
Come up, but I don't know how to do it.
Yeah, yeah. Okay. So I'll show you how to do it. So so I think post order, the definition was given, right? So if I have a search tree, or a binary search tree, or any search tree in general, so here we are only looking at binary search trees. So we have a search tree visiting in order. So I'm sorry, in order and post order. Yeah, in that. So I hope you remember binary search tree. So root is there. Unlike a heap where both the children should be smaller than the parent, here the left child is smaller and the right child has to be bigger. Okay. So in order traversal is when you first traverse through the left child, I mean traverse as in you output. Okay, you print the left child first, then the node or the current child, right? It's called a node. Node will have a right and a left child. So left current then right. So it is called LNR, left node right. And then post order is you finish with the children first, then you go to the parent or the root or the node or whatever. So left right current. You will understand it better with the next question I think. Okay, so a post order traversal, sorry, a post order traversal of a number search tree gives us 20 this long list. Okay, 22, 38, 28. So yeah, I'm being unreasonable I think. So yeah, 22, 38. So just remember, I have a search tree. So I start with the leftmost child. I mean whatever is there at the left, bottom left. Okay, then I climb in post order. So first left child, then right child, then the node. Okay, I think it will be clear when I explain it.
So let's say if it starts from the bottom, then what it will give is the smallest number, then the biggest number, and then the number in between them.
Yeah, something like that. Correct.
Say I can actually see 22, 28, 28 and 58 would be one binary tree.
Yeah,
One
wait. Okay,
binary.
so you don't have to answer now. I mean, that might be the answer, that might not be the answer. So you think within, I mean, you think in your mind. So 22, 28, 38, 28, 49, 48, 58, 61, 52, 45. Okay. So which of the following are correct? R means root. Root as in the topmost. Okay. Root is where it starts. R is the root. LR is the left child of the root, and RR is the right child of the root. So each child will have more children, right? So root is the top one. So which of the options is correct? You can either answer in poll, or if you find it more convenient, you can answer in the chat itself as soon as you're done. So in the end, I have actually I have a practice one where we practice how to write both post order and in order one. So let's do this first actually, then you can go and attempt these. Okay, is it fine? Do you want to solve that first, or do you want a practice session first? Just give a thumbs up if you want to do this first, or I'll just start a poll. So choose S if you want to attempt that first, and choose P if you want to practice this first. Okay. Yeah, but yeah, okay. Oh, you want to solve first? Okay, fine. Then you attempt that first, and then we'll practice later. So I'll go to this one. I'm not getting any votes in the poll, so never mind. So you have 5 minutes. Yeah, actually, I'll not start a poll. You just write the options in the chat. Okay, so there will be, of course, two right options here, one for LR and one for RR. And one more hint is that, so post one means left child, right child, and parent. So the last element here will be the root, right? The topmost one. So just keep that in mind. So time's up. I hope some of you got the answer. I don't see anything in the chat, but I'll anyway, let's just start to solve it. So I have this. So I have 22, 38, 28, 49, 48, 58, 61, 52 and 45. So what I know from this is, since I'm doing a post order traversal, so that is left node, right node, then main node, left child, right child, then main child. So 45 is the root. Okay, I know that. And since it is left, right and center or top, I know that 52 is the right child. Okay, 52. Now but as you know, 61 is not the left child. Okay, and it's also not the smallest one here. So how will I do it now? So let's start from the beginning, right? So I have 22, then I have 38. Okay, so I'll have 28 here. So yeah, this is one node and it's two children. It makes sense, right? Okay, so I'll wait, I'll just unmute. Oh, it's not unmute. Okay, so 28, 22, 38. So actually our thing is solved now, because all these numbers are greater than 28. Okay, sorry, are greater than yeah, 28. So I can't have any further children here. So I don't actually need to draw the whole thing. I can just say that the left child is 28 and the right one is 52. But if you want to draw the whole thing, how will it be? So that is also a way to how do I erase it? Medium erase. So let's just try to draw the whole root. Okay, sorry, the whole tree. So I have 45, then I have 28, then 52. These are two children, namely 22 and 38. Then 52 has two children, and they are of the same level. Okay, so don't mind. So I know that 49 has to be either the left child or the right child of something. Okay, since and after 49, 48 is there. So 49 can't be the left child of 48, and 49 also can't be the root, because sorry, not root, the uh, parent node. So I can write 48 here, and 49 will be the right child. Okay, so since 49 is bigger than 48, it is the right child, else it would have been the left child if 49 was smaller. So left, right, so smallest, largest, middle. So smallest is not here. I directly have a number which is large, so that is why I have so it has to be the right child of whatever is the next. Then I have 58, 60 and 61. So uh, so if I have uh, 58 here and its right child to be 61, that way I'll call 61 first, then 58, since I'll go to the children first, then the parent. So 58 is a child of 61. Since only one space is there, I can't say that it's the left child and the right child. Okay, so 58 is a child of 61. So 61, and since 58 is lower than that, it is a left child. So sorry for the lack of wisdom in using the space here, but was it clear how we drew this tree.
Would you explain the 58 and 61? That is where
Explain what 58 and this is 58.
58,
Sorry.
49 I understood that root and 58 and 61 I did not.
So we traverse the children first, then the parent, right?
Yes.
So you got how I got 48 and 49?
Yes, 52 is the parent we know, and then we know 49 and 48 should have been in. Uh, so I would have thought 48 would be the parent, and for I don't know, I wouldn't know. No, I didn't understand 49, 48 either.
Yeah, that's what I thought. So yeah. So see, 45 is there. So you know how we got this, right?
So from 45 to 52 to 28, 22, 38, I got it.
Yeah, fine. So I'll start here. 22, 38, 28. Okay, left, right, center. Then, so for this parent, this child is over now. Okay, now I'll go to the right part. So the right part, I'll again do a left, right, center for the left, right, center for the right, then the center, then the main parent, then the their parent. Okay, so I have 49 here, then 48. So normally what you see is smallest, largest, then middle. So here I have one number after 49 which is smaller than it. That means, and since 28 is already taken, that means 49 should be the right child of 48. Okay, so first children, then parents. So 49 has to be the right child of 48. And I know that 48 is less than 52. So 48 is the left child of 52 and 49 is the right child. So now left child is over. Now I'll go to the right child. Then I'll hit 52. Okay. So for this,
Sir,
once I'm done,
sir, sir,
yeah.
I hear that there should be the two traversals. Without the two traversals, we cannot predict the trees, sir. I
Yeah, I know. It's not like you need, but it is more helpful that way. If you have both, then you can actually predict the tree, the whole tree. But here I actually tried doing it with just this, and I think I got the answer. But anyway, like you said, it is better that we have both the traverses to actually be able to predict the tree. So that is why I think you're finding it a little vague, this 58-61 part. Okay. So since 48 is more than 49, it has to be the right child of 48. Okay. And say it's more than and before it. If it was after 49, then some vagueness would have been there, that is which one is the parent, which one is a root, or if it is a left child or the right child, right? See, if I had 48 before 49, then I can say that uh, 48 is the left child of the parent, or something like that. Some vagueness would have arisen, or I can say that both 48 and 49 are like one is left child or one is the right child. But since that is not the case, 48 and 49 is there like this, so I can conclude safely that 49 is the right child of this. Then I'll go to this 58 and 61. 58 is nothing but the, so yeah, 58 and 61. So since 61 is just before 52, right, I can say that 61 is the right child of this. Okay, so 52 was just before 45, so 52 is the right child of 45. And yeah, and you have to make sure that it is greater than this. right? Else if I had a number lower than this, that means there is no right child, only left child is there. Okay, so please keep that in mind. If I have a number that is lower than this before the last number, that means there is no right child, only left child is there. But since 52 is more than 45, so it is the right child, and 61 is right next to this, that means it is a right child of this. Okay. Okay, so one more way to understand this is like this. So and now we go to 58. So yeah, like she said, who said? Yeah, like Venkata Lakshmi said, uh,
Yes, sir.
it
Yes, sir.
it depends on how I look it. Okay, so if I start from the start, I'll get something like this. If I start from the back, I can I can say that this is uh, 58 is the left child of this, and 48 is the left child of 58, and so on. So that will be a little confusing for me. So yeah, so basically Inorder one gives you, yeah, a sorted tree. Okay, whatever you have, it will be in ascending order. So the nodes are visited in non decreasing order, right? So we go left child, parent, then right child. So small, middle, large. That's what we do. In post order, we ensure that the children are visited before the parent. So it is also so it is helpful when we are removing a node from this. Okay, and then yeah, so this is also this. So I wanted to do this actually. So this you can do yourself. I'll do this. So I mean it will be a little more clear if we actually go through this. Okay, so let's write the let's traverse this first in order. So what will it be, right? So first left child, so we'll start from the bottom leftmost. Okay, left child, not bottom leftmost, yeah, bottommost. Bottommost is this, but we go to the most left we can go, and then we'll do it, right? So first we'll get B, then C, I'll write it with space, then D. Okay, so B C D, then this root, right? So G, then I'll go to this, I'll come to the right child. So I have K here, I'll go down, so K, then L, then M. Okay, so see, I'm with BCD, I'm done with this, I'm done with this, then I have G, now I have to do this. Okay, so with KLM, I'm done with this. So the
Yes, I, J, and then KLM.
yeah, you're actually right. So first I, then J, then KLM. Yeah, my bad. So I have I, then J, then KLM. Okay, so I, J, then sorry, yeah, sorry. Then I'll come to the right child, I'll see if it has any more children, then I'll do the same thing. Then of course then what you do is simply then V, Y and Z, right? Wait, sorry, after I'm done with this, I'll go up R, then right, first left is now done. Now I'll write the parent R, then I'll come to right, so small, big, large. Okay, small, medium, large. So V, Y and Z. This actually it makes sense more or less. Okay, and you can see that it will also be in the ascending order according to your dictionary, this what I wrote here. Okay, so now let's see how we do post order traversal. So first, so I'll is this. So with post order, what we do is first children, then the parent. Okay. So first I'll take this. So first I'll target this left child, then right, then parent. So in left, I can see that there is left and right. So first this. So my first element will be B. Okay. So okay. Yeah. Will be B, then D, then C. Fine. So left child of G is over. Now right child. So I see that J is the parent and left child is I. So I'll write I. Then J is right child. J's right child is L, but L itself has two children, right? So K, so left, right, then center. So KML, sorry, not L. It was B, C, then I. My bad.
KMLG.
I. So K, L, M, sorry, K, M, L. Yeah. Then what? Right is done. Then parent J. Then parent, the main parent G. Okay. Fine. So left child is done. Now right child. So I have V, Z, Y. Then finally the root. So we can see that the root is at the end and Y is the right child, like just before the root is the right child, just before that is the right child of the right child. Okay, so that is how we do in order and post order. So using this you can actually predict this now. So we have alphabets A to R, not actually A to R. I have skipped a few, so I have A, B, C, D, F, K, M, P, Q, R. So post order is this, in order is this, like you can see in your screen. So yeah,
Do we
and
have
one.
pre-order? No, right?
Okay, so in this one it does not follow the dictionary order. Okay, it followed the dictionary order, so that's why we got an ascending order here. This does not follow the dictionary order. These don't have values 1 2 3 4 till 18. Okay, they have random values. So this thing, it says that Q is the smallest and R is the largest. Okay, so and they are in this specific order. So you just try to draw a tree on your own and you
I
find.
have one question. Is there something called pre-order as well, or it's just post order in order?
I think only post order and in order are there. So
Okay.
this means
I
it
was
is
just curious.
in order, right?
I was curious. I was expecting a pre-order. I was thinking how that was happening. Thank you. That's all my question.
Yeah. Oh, we have already exceeded the time, I feel. Okay, but we have to finish what we started. So this question you can actually find it on the in the drive and you solve it yourself. Okay, this task 1-1. Well, you have access to it, the drive, I hope. So I have this, and I want the right child of the left child of the root. Okay, right child of left child of root, and I want left child of right child of right child of root. So or if it is fine, you do this as homework, and or I'll start next week with this, so that I mean we have a little more time, right? So yeah, I think today's session didn't go as planned. I was being unreasonable with the time, and there was a small glitch with Google Colab. So yeah, I think we'll meet next week, and even next week I'll mention that we'll meet the week after that as well. Okay. So then, yeah, bye. Yeah, go on.
So I'll ask the question after you stop the recording.
After I what?
Stop the recording.
After I stop the recording. Oh yeah, you don't want yourself to be on YouTube, huh? Okay. Fine.